According to the question, when we expand this, the x to the power of 6 term is going to have a coefficient of minus 7. So this is going to give me something that is like minus 7x to the power of 6. And there is no term in x to the power of 5. So it will be plus 0 multiplied by x to the power of 5 and so on. And if I were to look at what I have on the left hand side, this is just an expression, and this it is going to, if I were to try to get this x to the power of 6 and x to the power of 5 term, here we got to conduct a binomial expansion. Let's do a bit of analysis first before we expand this second expression here. First of all, this q is independent of x, it's just a constant term. In order for me to ultimately get an x to the power of 6 and x to the power of 5, that means q, when multiplying this expression here, from this expression, we need to extract out two terms. Those terms must have x to the power of 6 and x to the power of 5 as its component, in order for this multiplied by this and this to get me x to the power of 6 and x to the power of 5. As for 2x, because there is already an x term, so if I were to multiply by this expression from this of 6, and the next term is going to be 6 choose 1, x to the power of 6 minus 1, which is 5, and that is what we want, and p to the power of 1 plus 6 choose 2, then x to the power of 6 minus 2, which is 4, and that is again what we want, then p to the power of 2. If I were to go for the next term, it is going to be x to the power of 6 minus 3, which is x to the power of 3, and that is already not what we want, so I'm going to just put a plus dot dot dot. This is equal to minus 7x to the power of 6 plus 0 of x to the power of 5 and so on. So this is 2x plus q multiplied by x to the power of 6 plus, here it will be 6p x to the power of 5. Here, if I were to press my calculator, it will be plus 15p squared x to the power of 4 and so on. This is equal to minus 7x to the power of 6 plus 0x to the power of 5. We need to expand this. X to the power of 6, and this multiplied by this is going to get us x to the power of 5, so I'm going to keep that term. It is going to be plus 30 of p squared x to the power of 5. This multiplied by this is getting me x to the power of 6, it is what I want, so plus q x to the power of 6. This multiplied by this, x to the power of 5, it is what I want, I'm going to keep that term, so this is going to be plus 6 pqx to the power of 5, and this times this, it is going to give me x to the power of 4. It is not what I want, so these are all the terms that I need. Plus dot 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 is equal to minus 7x to the power of 6 plus 0 x to the power of 5 and so on. Let's regroup them so that I can group all the x to the power of 6 and x to the power of 5 together. So what I will have is a 12p plus q x to the power of 6 plus 30 p squared plus 6pq x to the power of 5. This is minus 7x to the power of 6 plus 0x to the power of 5 and so on. Now if I were to compare both sides, what I can see is that this must be equal to minus 7. So 12p plus q, this is equal to minus 7. I'm going to call this my first equation. And this, comparing to this, that means 30p squared plus 6pq, this is going to be equal to 0. which means that if I were to factorize this, I'm going to factorize out 6p. It will give me a 5p plus q. This is equal to 0. And p should not be equal to 0. That is what the question says, which means that this cannot be 0. This implies that 5p plus q is going to be the one that is 0. And q can be expressed as minus 5p. This, I'm going to call it equation number 2. I have two equations. And this will give me the value of p to be equal to minus 1. And if I were to continue and substitute p is equal to minus 1 into this equation, equation number 2, then what we'll get is q to be minus 5 times minus 1. It is equal to 5.